Right. So both the Kani segment you are there?
Yes, sir.
Yes, sir.
Yeah. Right. Okay.
Sigmund, do you understand what I have explained?
Yes, yes.
Yeah. Well, I've understood. Thank you for that. But how do I link? What my actual question I didn't ask it properly was, how do I know that if you see this SGMC training GB101 inline helical gearbox, how do I know what are the bill of materials for this using this screen?
Yeah, if you see
So
the yellow color line, it shows the relationship between your header item and the component. For example, yellow color item on SGGB1,
Wait.
which is
I will
showing
explain
like
his
a
point.
component.
Kani, I will explain his point.
Okay.
See, the transaction code for display in the bill of material is CS03. Okay. Now this is the BOM for gear motor. Now I'm going inside this gear motor. No, it is having BOM of these items. This is having gearbox. This is having motor, and there are two components. This is clear, no?
this is level 1, right, sir? What we are
Level
seeing?
1. So here this is level 0. These are
Okay.
level 1.
Level 0. Yeah.
Gearbox, gear motor is level 0, but these 4 items are level 1. Is it clear?
Yes. Yes. Yes, sir.
Now
Yes,
this
sir.
gearbox, right? This is having further assembly. First, when I create BOM, you create BOM for this gear motor having these 4 items. That is one BOM you created. Is it clear?
Yes, sir. Yes, sir.
Now, to produce the gearbox, I need a BOM.
Correct.
Now, for that, I click this here. I go just to see the BOM. Now, I created BOM for GB1001. This GB1001 is having these things. What? Inline helical input one item, output one item, other 3 components.
Okay.
To produce the gearbox, I have these things. So this is another BOM I create. So using CS01, that is creation of BOM, I create the BOM of gear motor, where I use gearbox plus motor plus 2 components. Then I come to again other CS01, where I create BOM for gearbox again, but the gearbox is having input, output, and these 3 components. Is it clear?
Yes, sir.
This is again single level BOM for gearbox. Because this is to produce this gearbox, I need these things. This is a single level BOM. But this is becoming multi-level when it is linked to the gear motor. For example, when I have the gear motor, I have gearbox. This is single level.
Understood.
Now this gearbox, when I go and see that, then it is having further BOM, so it becoming multi-level BOM.
Multi-level, okay.
Now this inline helical, again I need to produce it. For that I have further BOM. So I go to CS01 for inline helical. I create the BOM where I give these things like cover 1, flange 1, input shot, bearing 1, bearing 2. So I'm putting all these. Again, this is another single BOM I create.
Understood.
So I have to create BOM individually for all these items as a single BOM. For example, first I will create through CS01 the gear motor BOM, which is having all these 5 components.
Yes.
Then I create another BOM which is having this inline helical gearbox with these components. Then I create BOM for input subassembly, which is having these components.
Okay. That is what Kenny was explaining. Understood. Okay.
Next, for output, I create another BOM.
Another
that was having this component.
The yellow one. Okay, I understood. Okay.
And then see here, out of these also, this particular input shaft. I'm not going to buy this. I'm going to do some subcontracting where I create another BOM from the raw material called input shaft forging. I'm going to produce it or subcontract it.
Okay.
So I created BOM for this. Is it clear?
Yeah, thank you. So thank you, Kenny. Yeah, understood.
Right. Now, this one, right, multi-level BOM, maybe if this is more clear for you, you can use this also. What is this BOM telling? Just a minute. Are we recording this? Yes.
Yes.
Recording is going on. Okay. Right. Now, here, what's happening? I have to create a gear motor. For gear motor, this is a gearbox used. But in this multi-level, what's happening? To produce a gearbox, I need this inline helical. Then I need inline helical input. Then I need output. Right? This is input. This is output.
This is easy to understand, sir.
And then
Okay.
I need this hexagonal bolt and then joining bolts. But to produce this input, I need to cover motor
Power
flange,
one.
input shaft. So it is completing the BOM of this level 1 up to the final level. And then in this 2, to produce it, there are third level BOM. Then it is going and completing them. Then it is taking the next second level of this item. For that, it is completing third and fourth.
Both. Then
Like that is it going. So depending on now you are feeling this is easy for you to understand. You can use this or that one, both.
How did you get this view, sir?
CS12.
CS12. Okay. Different transaction. I'll write it down.
That is CS11. This is CS12. This is CS11. This is CS12.
Understood.
Then there is a transaction called CS13.
Yes.
Here I execute this. Now it is exploding up to the last level and giving me all these requirements here. All the purchasing items. Are you getting? Is it okay? So this is CS13. Now I want to know a particular component, where is it used? For that I use CS15. Where used to list CS15. For example, I want to know this particular component TRNG CP1001. Where is it used? I have to click here, direct, then metal BOM, then I click here. So what is the quantity I want to see? For example, if I use one number, what will happen? So it is showing this is used in the input, like that is showing. Suppose if I select this item, that hexagonal bolt, for example, I execute this. See, now it is used in gearbox and gear motor, 2 places. I am using one number, like that it is used. Is it clear?
Yes, sir.
Are you okay, Kani?
Yes, sir.
Right. Now, okay. Rashid, are you okay?
Yes, sir. Yeah.
Right. So these are the, what is this? Okay, then let us do the comparison CS14 / and CS14. I just want to compare the SGMC -TRNG-IP 1001, and then I want to compare. Oh no, when I put something in the items, it is taking time. I don't know why. Right, let it come. Okay, let it come. So these are the reports related to BoM. Okay, so please go through this BoM and practice yourself. Mass change and all, let us not practice it as of now. Once you are familiar with the transaction, you can try it. Maybe you can refer this metal to change it. Okay, right. So with this, we are completing the discussion on the BoM. So next, we will be going to, just a minute. So this is the BoM structure we are using. Okay, like a gear motor, where we are using the gearbox, motor, other things. And then to put the gearbox, we have this input subassembly. These are all the BoMs. And then we are having the output. These are all the BoM items for the output. And then we are having the oil here. This is what is the BoM structure in Excel file. Right? So that you will get more clarity. I will share this also. Right. Now, let us go to work center. So, again, as part of the overview of master data for production planning, we discussed about metal master. We discussed about bill of materials. So now we are going to discuss about work centers. So work center is where an operation or activity is carried out within the plant. So it is a part within the plant, which is a master data. Work center is a master data. Work centers are used in routings, networks, inspection plan, and maintenance routings. So routing means it is for production. In case of that process industry, it is called as master recipe. Yes, the work center is called as a resource. In case of master recipe, work center is called as a resource. And work center is used in routings, network. Network is a project. Inspection plan is for quality. Maintenance means, the maintenance, plant maintenance and all. So work center can be an individual machine, or it can be a production line, or it can be an individual person or group of people, or it may be a manufacturing cell. These are the examples of work centers. So work center is used for capacity planning. For example, I have BoM to do the planning of materials. I can buy the materials, but I need to produce. The production is happening at the work centers. So this production at the work centers, I need to understand the capacity of the work center. So based on the formula defined in work centers, capacity planning can be done. Please take note, the capacity of work centers are limited. For example, maximum we have 24 hours per day, not more than this. But when you get the order from customer, it may be huge also you can get. For example, your production capacity for the day is 20 metric tons. But you will get the requirement for 50 tons also. So, but you cannot produce because your capacity is only 20 tons. So you have to do the capacity planning because it is finite, it's limited. Also, it is used for production scheduling. So the available capacity has to be scheduled in such a way that they are executed efficiently. Again, we can give the scheduling formula in the system. And then work centers are used to assign the cost to the right work cost center. So we need to get the formula for product costing, which is defined in work centers. That will be used for costing purpose. In this work center, if you do the job, this is the permanent cost. That is what we can assign in the work centers. Since product costing is not part of our discussion, we will not go into detail about this, but I will show you where it is maintained, what are we maintaining there. So first we have to see in the work centers, what is the available capacity? What is the available capacity? So what is the meaning of available capacity? This we discussed as part of CSCP. Also we discussed in the MSME course. Also this is part of discussion CLTD also. For example, if you take one machine, that machine is available for example, here the example is given here. The factory is working in 2 shifts, for example. A factory is working in 2 shifts. Total hours of the shift working is 8 into 2, 16 hours. For example, you take one machine which is running in 2 shifts, so total it is 16 hours. That is the total time. At the same time, in one shift, there may be 15 minutes required for cleaning, 30 minutes required for lunch break, 15 minutes required for tea break. 15 minutes for cleaning, 30 minutes for lunch break, and 15 minutes for tea break. For each shift, combining these 60 minutes is gone. So which means what is available time? We have only remaining 7 hours for each shift. This means we have 14 hours only available. Total 16 hours, but you have only 14 hours. If you have 2 machines, then 2 machine into 2 into 8, 32 hours. And then break is 120, which is 2 hours. Remove these things, we are getting 28 hours. So we cannot take all the 24 hours, sorry, whatever it is, 2 shift means 16 hours, 3 shift means 24 hours as available capacity. We need to remove these kind of time which is really required. And so we have to take only the balance thing to see what is the available capacity. Is it clear?
Yes, sir.
So the required capacity is the number of hours required to produce a product. So that is available capacity. Now we go for required capacity. The required capacity, where it is coming from routing of the product. For example, I create a production order. I create a production order for 100 numbers. To produce it, I need this much setup time. I need this much processing time. These things are coming through routing. So that is my required capacity. So there is a capacity available in one place. There is a capacity required, which is coming from the orders. Now, for example, there is a work center. Okay. Here I have shifts, 3 shifts. The hours are 8 hours total. So the total hours is 3 into 8, 24. But the break, as I told, that is 15 plus 15 plus 30 minutes, which is 1 hour. That is for each shift, which means 1 into 3. is 1 into 3. This means available hours is 24 minus 3. 21 hours only available. This is for one work center. This is for one work center. One work center. But if I have two, what will happen now? We have two work centers for this machine. Then it will be this into 2. $42 hours only, not 48 hours. No, for if I have 2 means actual total hours is what? It is equal to maybe here I can do 48 hours are available, but now break is this also into 2. So my remaining time is only 42 hours. It is not 48 hours. I have only 42 hours. Now I have a production order. I have a production order where to produce the product, my setup time is 1 hour. The setup time is 1 hour. My processing time is 0.5 hours per piece. This is my standard time. Setup time, process time. Setup time is 1 hour. This is 0.5. Now, if I need a production order, production quantity for 30 pieces, for example, what is the time required? What will be the time required for setup? What is the time required for setup?
1 hour, sir. Same 1 hour.
Is it okay?
Say 1 hour, no?
Sigmund? Yeah. Is it okay, Sigmund and Rashid?
Yes, sir.
Yes, yes, sir.
So we need
Setup
1
time
hour for setup. Processing, how much
Yeah,
we need?
30
15
multiplied
hours.
by
15 hours. 13 into 0.5,
Five.
15 hours. So what is the total time required?
16 hours.
16 hours.
So here my required capacity is 16 hours. Is it clear? Or this is the available capacity. This is called as required capacity, or this is called as load. This is a load. The load is coming from my production order and the standard time I maintain the routing. These are maintained in the routing. This is maintained the routing, and this is the production order. Is it clear?
Yes.
Now, apart from this, there are two other factors here. The machine, what is there? Normally, we know the efficiency of this machine, right? It is a theoretical calculation what we did here. Okay. Theoretically, we are telling 21 hours available, but normally this is 90% only efficiency. So what is my actual available hours?
90% of 21.
This into this. So finally, I have to compare this only against this load. I cannot compare 16 with 24. Then it is wrong. Similarly, I cannot compare 16 with 21. That is also not correct. I have to compare 16 with 18.9. Suppose if I get the quantity of 35, what's happening? My load is becoming 18.5, and this is just to match my capacity. It is just to make my capacity. That's it. Suppose if I get 40 numbers as order, then my capacity is occupied more, which means that my capacity is limitation. Is it clear?
Yes.
So when you compare the
Can you
capacity,
repeat it once again, sir, please, sir? Please, sorry.
So you are clear up to this?
Yes, sir. I just missed efficiency and availability, sir.
Okay. Now I have this machine available based on this calculation. This is clear, no? Whatever I put the shade here. At
Yes,
the
sir.
same time, whenever I run the machine, this is theoretical available hours. If the machine is perfectly running, I am having 21 hours from that machine. But in between, I get some maintenance problem or some other issue. Because of these things, the efficiency of the machine normally it is 90%. So what we take this H, available hours, 21 hours, it is 100% efficiency. But in industry, most of the machines, they do not run at the 100% efficiency. So we have to give some efficiency factor there. That is what put in efficiency. If we consider efficiency, what is my available time? That is 21 and 90% of 21, which is 18.9 hours. Is it clear?
Yes, sir.
Similarly, if I have two machines, then it is 90% of 42, so 37.8. So my available time, it is not the total hours, 24 and 48. It is not that available hours after reducing the break, which is a break I have to give. And then my efficiency, if I consider actual available hour is this. If I have one work center, it is 19 hours. If I have two work centers, then I have this one. Is it clear?
Yes, sir.
Now based on this routine time, setup time and processing time, if I put the production quantity like this, if I put like 30 pieces, my capacity, the load is 16 hours, which means I am comfortable with the capacity. Is it okay? My load versus
Yes, sir.
capacity is fine. For example, capacity utilization will be 16 divided by 18.9. This is my capacity utilization.
Yes, sir. Yes, sir.
Suppose if I get the production order for 85, 35, what's
Fine.
happening? My capacity has become 97.88. Correct?
Yes, sir.
So we are almost in the border. If I get 40 pieces, then it is become 111%.
Gone.
It means I am overloaded.
Overload.
Is it clear?
Yes, sir.
Right. So this is the work center capacity details. Now, this is what we have to determine the capacity using the details. So determine the capacity, we need to have these things. Okay. Oh, meeting will be over in 10 minutes. Okay. Right. So in work center, if you take, there are many details which are available as shown here. In work center, there is a area called standard value key, which will be covering like a setup time, machine time, labor time example. In routing, for each of these setup time, we maintain the time for the product. For example, as we shown in the example here, to produce the product, setup time 1 hour, processing time 0.5 hours. These things I maintain in the routing. So the work center is telling what are the things I am going to capture. I am going to capture setup time. I am going to capture the machine time. That is what in work center will define. But what is the value of these things? I will maintain the routing. For example, setup time is 1 hour. Process time is 0.5 hour per piece. That I will maintain the routing. Based on this, system will arrive at what is the capacity and what is the load required, which is coming from production order. The production order which I told you the example, the 25 pieces, 30 pieces, 35 pieces. It is comparing with the machine capacity. Now we are quoting what is the capacity calculation and balancing. This is how the capacity will be calculated. These things I explained in the Excel now. So now this is an example. For example, base quantity is 100 pieces. setter time 100 minutes, machine time 200 minutes. That is 200 minutes required to produce 100 pieces. It is not per piece, it is to produce 100 pieces. Labor time is 400 minutes, let us say. So which means if you need to produce 200 pieces, then setter time will be 100. My processing time, machine time is 200 into 2, which is 400, which means I need 500 minutes of machine. 500 minutes of machine. That is the time required, or the machine capacity required from this formula. So the machine time, the processing time, which is variable with respect to production, like what we discussed in bill of material, the base quantity also we have to define. This 200 minutes, is it for 100 pieces or 200 minutes for single piece? That we have to define. In the Excel file, what I explained to you, I maintained that for per piece, for individual piece. But here in this example, I'm showing the slide, this is for 100 pieces. So if I want to produce 200 pieces, my time required or the capacity required will be this much. Then scheduling is determining what is the start date and finish date for the each operation. And the scheduling should help us to adhere to the customer requirements. Effective scheduling is very much required. Also, there are some advanced manufacturing concepts like JIT, lean, etc. They are properly possible only with the right scheduling. The scheduling here, it helps to sequence the operations. Resource.
Sir, what is that jet lean processing, sir?
Huh?
What is that jet lean processing? Before you show me advanced manufacturing concept like JIT, lean,
JIT is called just in time. JIT is called just in time. Just in time means this is automobile companies. When they produce a car, right, they do not keep all the spares in their stores or something like that. They will keep only the components in the shelf, which is near the production. So they will ask the suppliers to fill the stock 15 minutes or half an hour before the production which is required. That is called just in time. Just in time means when it is required, it has to come. Lean concept is I want to maintain like zero stock or minimum stock for like a WEP and other things. I will keep producing only when it is required. That is called lean concept. These are all some different big concepts. These are all focusing on reducing the inventory in the production and all. And to achieve these things, very, very difficult task. You should have your quality maintained properly. You should have your system high flexible. Many things are there. But just for this understanding purpose, you take it as JIT. JIT means just in time. Lean means a lean concept, where we have very just in time means it's related to schedule. At the time it has to come. Lean means you have to maintain very minimum inventory. So scheduling involves sequence of operations, resource allocation, assigning the job to works and tests, start time, finish time, and material issue times. So scheduling can be happening either forward scheduling or backward scheduling. What is forward scheduling? Forward scheduling is we plan the activity in the forward direction. I mean, I start from today and then when I'm going to complete. I arrive at the finish date based on the forward scheduling. Forward scheduling is helping to arrive at what is the finish date. I am starting today when I'm going to finish it. That is called the forward scheduling. So what is the backward scheduling? Backward scheduling is I have a date on which the product is required or customer date is required. Then I arrive at what is my starting date. That is called backward scheduling. So forward scheduling is used to arrive at what is going to be my finish date. And backward scheduling is used to arrive at what should be my starting date.
So can you give an example of backward scheduling, please, sir?
Now, this is the schedule. Here, I have the customer target date, order finish date. Here, I know that each operation, what is the time required. Float after production, float before production means I have some cushion here. For example, after completing the production, I need to clean something. Apart from the operation, I need to do some cleaning and all. Float before production means I need to do some arrangements to give the materials and other things. Those time also include. So my customer is asking the.
Sir, this is related to the scheduling.
Yes, it is there also. Yes. Yes. Now, for example, we are on 23rd July. Customer is asking on 31st July the material. Then this will be taken as a reference, 31st July. System will see the days and operation times. Then it will say that you have to start it on 26th July, this production.
And this is backward.
This is backward.
Oh, okay.
Forward means I am on 23rd. Considering these things, I will complete this on 26th. So I am arriving at my finish date. That is forward scheduling. So forward scheduling is I am starting now when I will complete. Backward is I have a target date. To achieve the target, when should I start? So forward scheduling start from the planned order release date, when I am to start. From the start date, subsequent activities are scheduled. It helps to complete the task in advance. And also it confirms the earliest possible time to the customer requirements. At the same time, if the materials are not shipped after completion, it may lead to inventory pile-up. Forward scheduling. Backward scheduling, I am starting from the customer date, from the due date. It helps to plan the resources as needed. Now I am utilizing the resources as per the requirement so that I am getting the start date. But if I start as per the date, in between, if there are some constraints in my resources, that may lead to some delay also. So that is a constraint. So the organizations will see which is good for them. Then they will define what is the forward scheduling or backward scheduling. We'll continue the discussion after taking this break now for the recording.